Hi, everybody, and thanks for joining us today in this e-workshop dedicated to total sample preparation workflow for environmental analysis. I'm Giulio Colnaghi, and I'm the marketing manager here at Milestone. And today, during my presentation, we will go through the environmental testing lab's needs. Then we will take a look on why you should consider the total workflow approach and how to practically improve your workflow for meta-analysis and organic pollutant analysis. So when we consider an environmental testing labs, we know that is dealing with different kind of sample, both solid and aqueous, such as wastewater, but also soil, sediments, and many other matrices. At the same time, the lab offers a full suite of analysis, so metal testing, organic pollutant determination, emerging contaminants, microbiology, and even wet chemistry parameters. So the lab has to offer all these solutions, but also has to consider a lot of different challenges. First of all, it's a very competitive market, where high productivity and the cost of analysis are pivotal for the profitability of the lab. Is also very regulated, so there are specific metrics to address, and they have to be open and quick to adopt a new regulation with lower action and reporting limits. Also, the laboratories has to deal with rush samples and fixed turnaround time due to some commitments of some contract. And therefore, taking in consideration the sample prep is important because sometimes can be the bottleneck of the entire analysis process. But there are also other bottlenecks, such as the supply chain issue, for example, for the reagents or for other consumables. Also, the laboratory has to take in consideration the safety of their employees, considering that they are exposed to hazardous acid and solvent, and they have limited access or limited space under the fume hood. Also, the staff is suffering of high turnover, and often those laboratories have to perform more, doing more with less. So it's a very complicated environment on which the lab has to move, and therefore looking at new solutions and looking to address the entire workflow is pivotal to secure a better balance for the lab. When we look to the journey from sample to analysis, we have our samples, and there are several steps to get to the analysis. Each of these steps, when you consider the total workflow, has a direct impact on cost, on the quality, on the efficiency, as well on the safety of the lab. So looking at the entire sample preparation workflow, it's important because it can boost the quality of the lab, the efficiency, it can increase the safety, but at the same time, it can lower the cost of analysis. When we consider the sample preparation workflow, or better, when we consider the path from sample to analysis, ideally, we want to reduce as much as possible all the steps. So eliminating the sample preparation is the ideal scenario. But the second option is a path to optimize all the sample preparation steps and make a smoother transition from sample to the analysis. So when we consider the elimination of the sample preparation, this is clearly not feasible for several analyses and for several solid samples. But it is feasible for mercury analysis, for example, where we can directly determine mercury in environmental matrices without any sample preparation step. In fact, by using a direct mercury analyzer, we can take the sample as it is, both solid and liquid, and we can introduce directly the sample into the direct mercury analyzer, and within 6 minutes, we are able to get the total mercury content of our sample. This is clearly a streamlined path that provide a better turnaround time for the lab, enhance the productivity of the lab, but at the same time reduce the cost because we have not to deal with all the sample preparation steps. We can also eliminate the risk of losing volatile species of mercury, which can happen during the sample preparation process. And we reduce the waste because we are not longer use any chemical during the sample preparation. And therefore, we also do not expose the operator to hazardous substances. If this is true for mercury, this is not feasible for many other metals, and also when we are dealing with organic pollutant analysis. So how can we optimize those steps, and which are these steps that can be optimized? There are several steps in metal analysis that can be optimized. Here you have a summary of the one that we will touch today. So we have the supply, the acid supply, we have the reagent handling, we have the vessel handling, then the microwave digestion. Then once we have done our digestion, we have to go through a filtration to separate the solid from the solution, and then we can go to the analysis, but at the same time, we need to clean our vessels to make sure that we have a vessel ready to restart the entire process. If we look to the workflow for organic pollutant, the sequence in some ways is similar. So we still have to handle the reagent, we still need to handle the vessel, we still need to go through an extraction process, a filtration process, then sometimes evaporation is also performed, and then we need to have also here the cleaning of our vessels, and of course we have our analysis. So how can we optimize those steps, and which is the best approach? So starting from the acid quality supply, if we need to work with high purity acid, we need to take in consideration that this is one of the most important parameter during our analysis, because it is widely used for preparing our sample, and so has a direct impact on the detection limits and on the blank, but also is an expensive reagent and is an expensive part of the process. And when you think about the routine of an environmental contract lab, it can also be contaminated during the different handling of the bottle. And if we are not able to get the acid due to some supply chain issue, we also face workflow disruption. The quality of the acid is key because often it is used for ICP and ICP-MS analysis, but also for cold vapor atomic fluorescence and cold vapor atomic absorption analysis. A good way to address this challenge is to use an in-house subboiling acid purification system that enable to purify reagent-grade acid into high-purity acid, and therefore cut not only the cost of the reagent, but enable the lab to in-house produce the quality of the acid that they need to perform the different kind of analysis. From the quality of the reagents, we move to the reagent handling, and this part is true for both metals and organic pollutant analysis. In both cases, we need to work with hazardous reagents, either concentrated acid or solvent. This step is typically done manually and expose the operator to those concentrated acid and solvent. It also requires a lot of operator time, and also here during the addition of the reagent we can face contamination. Plus, since it is a very repetitive operation, it can suffer of consistency, and therefore you can face issue at the analysis later on. A good way to address this challenge is to use an automating dosage station, where we can simply place our vessel with our sample, and the system automatically dose the different kind of reagents, both acid or solvent, depending on the type of analysis that we want to perform, into our vessels. And this eliminates completely the exposure to acid and to solvent of the operator. Plus, it standardizes a manual approach that is typically taking away a lot of operator time. Now we move from the reagent handling to the vessel handling. So we have our vessel, we have our sample, and we have inside either the acid or the solvent. So we need to seal properly the vessel. This is another important task, because consistent closure secure consistent results. Plus, is done manually by the operator, so it's taking also away operator time, and that therefore has a direct impact on the productivity, and it is also a very tedious operation. So there are automatic capping stations that can enhance this step for both metals and organic pollutant analysis, and can simplify this operation and can ensure consistency over time in order to have a better flow of sample from the reagent handling to the microwave digestion or to the microwave extraction, which is what we are going to see now. So when we talk about analysis of metals, we have to go through a microwave digestion process. When instead we want to consider the organic pollutant analysis, we need to go through a microwave extraction process. In both cases, we need to recover the target analytes of interest, and we need to avoid venting during the run. Otherwise, we can lose volatile compounds or elements during the process. It's also important that this step provides the productivity that the lab is looking for, and also is a reliable process so that we can avoid the sample reprocessing. At the same time, typically those steps are done with a low volume of reagents so that we have lower blanks during the analysis. The solution to address both these tasks for digestion and extraction is microwave digestion and microwave extraction, where we have dedicated accessories, rotos, for performing digestion from 24 to 44 position, as well as we have a dedicated accessory, an extraction rotor with 24 position that works with disposable glass vials and enable the simultaneous extraction of 24 position in only 40 minutes. Moving from microwave digestion and extraction to the filtration, because we need, after these processes, to filter and separate the solid particles from the liquid. This also, it's a very challenging step, because it impacts the productivity, is typically done with filter paper under fume hood, is very time consuming, and often it takes a lot of space under fume hood, reducing the work area for the operators. A good way to address this challenge is to use a simultaneous filtration system with multiple positions and connected to vacuum that enable in a small footprint to perform the filtration of up to 24 positions, either after the digestion process for metal analysis or after the extraction process for organic pollutant analysis. And this offer an ergonomic way to filter the sample after the digestion and the extraction process. The last step that can be optimized is the vessel cleaning. And also here we have different options. When we consider this step, we need also to consider that is a tedious procedure, takes a lot of time, often is done in an acid bath or is done through a microwave digestion or extraction system. But it's key to consider that when you use the microwave unit to perform your cleaning cycles, you dramatically reduce the productivity. And if the cleaning is not done properly, you also face high blanks. Plus, you can have high volume of acid used to perform only the cleaning cycles or in the acid bath. And when you deal with acid bath, you also expose the operator to some safety concern due to the volume of acid that is used. A good way to address this issue is to use an automated acid steam cleaning system that can perfectly fit in the metal analysis and enables an efficient cleaning of our vessels, of our glassware, and doesn't expose the operator to any safety concern. When we talk about organic pollutant analysis, the solution is to use disposable glass vials that completely eliminate the need of performing a cleaning cycle and enable the lab to be even more productive and to improve even the turnaround time. So we have seen through the entire workflow for metal analysis that there are different steps and how those steps can be addressed through the use of a dedicated tool that can simplify and expedite that specific step of the sample preparation. The same is done also for organic pollutant analysis, where there are dedicated tools that can fit the whole left from the sample to analysis journey. So the total sample preparation workflow approach aims to optimize the cost of the analysis, and this can be done by using an in-house subboiling purification system, for example, or to increase the quality of our analysis through a better digestion or a better extraction process, or to enhance the efficiency through the use of disposable glass vials that completely eliminate the cleaning step, and even to increase the safety, and for example, with the use of an automated reagent dosing system that does the work of the operator without exposing the operator to hazardous chemicals. I hope my overview of the total sample preparation workflow approach was clear, and I suggest you to continue to follow our e-workshop to have a more in-depth explanation of our approach. Thank you and have a good day. Bye.